Hello, my name is Marius. I'm currently working for Bigstep. Um, I'm going to talk to you today about how to automate big data applications with Ansible. Um, First off, I was thinking of asking you a couple of questions. Did any of you try to install Hadoop? Has anybody done that using Ansible? Great. So we have someone who did that. Very good. So a little bit about the presentation. I'm gonna tell you about why we chose Ansible and how we went about using it to provision our own infrastructure for our own application. After which I'm going to tell you how we started implementing provisioning big data applications for our customers automatically on our platform. And go a little bit into specifics of how we're doing that. Some tips and tricks and what we've learned while using Ansible, what are important things to note. And then I'm going to tell you what we plan to do for the future using Ansible and what we want to do there. So a little bit about me. Currently I'm IT Operations Manager for Bigstep. I started in 2007 doing tech support, after which I quickly went to a systems administration position. I did that for about, I think, 6 years. And last year I went to IT Operation Manager for Bigstep. I'm very passionate about improving things and system operations in general, and I totally dislike repetitive tasks. So that's why partly I chose Ansible. Bigstep, the company I work for, is the highest performance bare metal cloud. So we have storage nodes and compute nodes. The compute nodes are physical entirely, so no virtualization is involved. They don't have any physical disks in them, so we boot the operating system from our storage. Each rack of servers has its own storage, so we have distributed storage around our infrastructure. Our network is very, very fast because we use cut-through switching, so it's a lot faster than traditional network. All of this is done automatically. We have like an interface in which you drag and drop servers, and you just click deploy, and you have them in 3 minutes, 5 minutes, things like that, depending on the size of the cluster. So this is our infrastructure part. We also started building, I think about half a year ago, big data application support. So we currently automatically install applications like Cloudera, which has Hadoop, Elasticsearch, Splunk, Couchbase, and a couple of others. This is done very easily. It's a one-click deploy, and you get the whole cluster pre-configured for you. You just access it, put your data, and you get everything. So this is currently our production infrastructure here in UK in a data center. This is actually the second version of what we have. The first version was done very quickly. It wasn't done so that we would have redundancy. And at one point we said, okay, we have to redo everything and do it properly. At that point, we discovered Ansible, and everything you see here is configured automatically through Ansible. So we have load balancers, we have application servers, MySQL servers that are automatically configured into master application and things like that. Right now we're currently expanding, so we're going to have a new data center in Germany, and it's very easy for us to just replicate this environment, that has redundancy and has everything. So it's very easy for us to just use the same playbooks and same configuration for the second data center. This is kind of like our main playbook. So we have a bunch of roles that run on different types of servers. We have a common role that does a bunch of things on all types of nodes, MySQL nodes, app nodes, load balancers, and things like that. The common role, actually, we use in our infrastructure. We have both CentOS and Ubuntu. With Ansible, it was very easy for us to make the common role provision the same things on both Ubuntu and CentOS. So it's very easy to do that. Here we have multiple environments. So we have like an integration environment, we have a staging environment, so we have a development environment. Actually, we have two types of development environments: one for the developers and one for us to test the playbooks. So, for example, for testing this playbook, we use Vagrant. We spun up like 14 virtual machines. And after the machines are up, we start running the playbook. So, for example, I can quickly show you. So these are some machines that we have. Vagrant is pretty slow. So if I just do Vagrant up, the machine will start to power on. This will take probably a long time. I will continue. So for instance, I can do an ad hoc command and check that the hosts are up, the machines are up. So this is the only one that started for now. I will try another one. I will show you how we will continue with this later. With the mouse. So this is how we test our playbooks to see if anything fails or if we make any substantial changes, if it still works as it should, if the configuration files are set up properly. So after we did this, we wanted to for our customers to be able to easily provision big clusters of servers. So we built these apps. So what an app basically is there are a bunch of servers that automatically get installed with Cloudera, let's say, or Couchbase, or Splunk, or other big data applications. So, for example, you could easily grow a cluster, and using Ansible, we provision the new nodes, and then we reconfigure the application to use those nodes. So we have inside our own application, we have a bunch of drivers. We have a storage driver that talks to the storage directly. We have a switch driver that provisions the network interfaces for the servers. We have some OS drivers that, for instance, add an SSH key to the server when it's provisioned. And as I said, we have some app drivers. Actually, we have API drivers and Ansible drivers. So basically, what happens is after the nodes get provisioned, Ansible goes in, installs and configures the application, and then we, through the own application's API, we configure the application and add the node. So, for example, this is an Elasticsearch example. On the left, you see that we have two instance arrays. An instance array can contain one or more nodes. We have an instance array that has master Elasticsearch nodes and an instance array that has data nodes, two data nodes actually. If you would click one of those, you have a tab like a SAS tab, and there you can get more information on your cluster. For example, you can see the Elasticsearch version, the CPU usage, the memory. You would also have URLs for HQ and Paramedic. These are some Elasticsearch visualization plugins. In the back end, what Ansible is doing is installing Elasticsearch using three main roles. So we have a common role that runs on all types of nodes, and we have some dedicated roles for specifics like data nodes or master nodes. Kind of the same thing for Cloudera. So right here, there's a 9-node cluster. We have 8 8 data node clusters and the head node. As you can see, we have some information about the cluster in this tab and an URL to actually access Cloudera, the Cloudera interface. Here, as I said, we after it all gets provisioned using Ansible, we also connect to the Cloudera API to be able to do things like add a new node to the cluster, select different roles like a data node role inside Cloudera. Also, what's important, we are able to scale up and scale down easily. So, for example, for scaling down, it's very important to have data integrity. So, prior to decommissioning the node, we do data eviction from that node using the Cloudera APIs. We also we do these kind of things using the APIs for different applications. For example, Exasol, which is a very fast database. We do kind of the same thing. We use their APIs to add nodes to the Exasol cluster or remove nodes and remove data prior to actually deleting a node. So why did we choose Ansible? Well, of course, it's very, very easy to use. I think the main thing was that it uses SSH and it's agentless because security is very important in every company, I think. So that was one of the main reasons. But also, it uses very simple YAML format to write the tasks and to do things with it. It's important and reusable, so you could easily run the same tasks over and over again. You would get the same outcome. It's very easily extensible. So, for example, at first we made an Ansible module that talked directly to the Cloudera APIs, and it was not very hard to do. But because we were connecting to those APIs from our own product, we thought it was better for us to use the same things to modify and add the cluster. So a couple of things we've learned. Name is very important. Using name when creating tasks is very useful for documentation. So I'm thinking that nobody likes to write documentation. So just having that name helps a lot and helps a lot of people that look into those files later on. So let's say someone leaves and you don't know exactly what's happening, how your infrastructure is configured. When someone else comes along, it's easy for them to pick up where the other one left off. Also important is to test playbooks. So if you want to check for syntax errors or stuff, you could use --syntax-check. This goes through all your YAML files and tells you if you have any syntax errors. --check actually goes into the servers, does sort of a dry run, and tells you what has changed. If you have something that changed, let's say a configuration file, you could easily use --diff to see what has changed in that file, what's new and what's old. I actually had a problem a couple of weeks ago. I changed in the, I don't know if you know, but in Ansible.cfg file, you can set an Ansible managed text, and you can then add that as a variable in config files. So you know that that configuration file is being managed using Ansible. So I changed that text, and all my configuration files got changed, and I couldn't figure out why. And then after I did the --diff, I saw that was the only thing that changed in the configuration. Tags are very, very useful. So let's say you have a very big playbook with a dozen rows or things like that, and you can run just some specific tasks that have the specific tag and nothing else from that playbook. Also very useful --start tag. So let's say that something failed, I don't know, SSH timed out, or some handler didn't restart properly because of the configuration file, or misconfiguration file. So you can just say --start at and the name of the task that you want to start at, and you can just continue from there to run your playbook. --step is very useful as well. So let's say you want to run some specific tasks in your playbook, but you want to be able to move past some tasks, not run them, not do anything with them. You can, when you use --step, it asks you every time if you want to run the task, and it goes to the next one if you skip it, or it runs that task and then goes to the next one. --limit is also very powerful. So, for instance, if you're doing a rolling upgrade, you can just update some. If you have, let's say, 10 web servers, you can just update 5, and then the next 5. You could also, if you have like MySQL servers and web servers, you could easily just run some tasks on the web servers, but not the MySQL servers if you're having some, I don't know, mixed tasks. I find it very useful to put time in front of Ansible-playbook, so you always know how long it will take if you do a run afterwards. I don't know if you need to do a run at night, or to be able to know how long it's going to take. Maybe go grab a cup of coffee in the future. The docs are very, very useful, so they get updated constantly, and all the new features are listed there. So this is it's very useful to go and read them now and then. So, like I was telling you, we have some things that we are currently want to integrate Ansible in. So we have Botstep, which is a ChatOps bot that we use for Slack, and we would like to be able to integrate Ansible in that, so we could do like integration and staging deploys for now, and maybe even production for the future. We've just recently discovered Rundeck, which is pretty powerful for running jobs, running different jobs, and we'd like to see if we can somehow integrate Ansible with that. We also have plans to creating our own Ansible cloud module, so I'm guessing that most of you are using the EC2 to provision nodes, new servers in AWS, so we would like to be able to do the same thing in Bigstep using Ansible. We are also working on a deeper integration between our Ansible apps driver to see and maybe even expose to the customer what has been done on that cluster when provisioning or when expanding the cluster or shrinking it. Also, we're working on being able to do major app upgrades. So, for instance, right now we automatically install Cloudera 5.1, and we want to add a button, let's say upgrade, and the customer could easily say upgrade, and we would upgrade that whole cluster to 5.3. Since this upgrading things automatically, it's not always safe, we plan on implementing the snapshotting, so we do a snapshot of all the servers prior to upgrading. In case anything fails, we can easily roll back. Even if we don't see any failure, and the customer has some issues that we haven't noticed, he would be able to easily go back and say, I want to revert back to the previous version of the application. So I think that's about it. Thank you. Don't forget, go bare metal. So now I can show you the. So I think the machines are up. If I do a ping, you can see all the servers are up. The Vagrant file is very easy to set up and not very complicated. So you see I have a bunch of nodes, and in this section here I just configure them a little, and then they power on. So it's very, very straightforward and very easy to do. Also, I have 16 gigs of RAM, and I can have these many machines on my laptop. So we can run something like this, for instance, and we will start checking if everything happens. I have an issue because Vagrant is resetting my my host name, so every time I run this playbook, it will reset up the host name as they're set up differently. Sure. Is that good?
Even more.
That's all right. Oh, okay, okay. Yeah. Yeah. Well, I'm not going to show you how it's, I don't know why it's taking this long, it's usually faster. As you can see, I'm using time here, as I said, to time my place. So I think that's about it. Thank you. Do you have any questions? Sure. Yeah.
So we were talking about snapshotting machines.
Yeah.
And you entered with Go bare metal. So what's your strategy for snapshotting bare metal?
Well, as I said in the beginning, we don't actually have physical disks in the compute nodes. So we have, let's say, centralized storage, centralized but located in the same rack. So we are able to do snapshotting because there are we use volumes right in there. It's and we can easily snapshot the volume that's located on our storage because we use the network to transport the operating system to the compute nodes. So we just, if you just, after you create a snapshot, you just do a restart of the node if you want to revert back and you have everything back as it was.
So if we've got some more questions, if you want to stick your hand up, then I'll try and get to you with a microphone. That's an easy one.
Yeah, I was just wondering, so you're doing upgrades of pre-existing clusters as well, or just pushing out new with the playbooks? Can you talk a bit about what we've done as far as rollbacks concerned?
Okay, so you're talking about application clusters. So we plan on doing updates for existing clusters as well. So right now, as I said, for Cloudera, for instance, we have 5.1, we provision 5.1. But we plan on having an upgrade button when the customer would like it, just pressing that button, and we do a sort of a rolling upgrade of the whole cluster for Cloudera to the latest version 5.3. Prior to actually upgrading, we could do snapshotting of each volume of each node. So in case anything fails during that upgrade, or in case the customer would like to roll back, we would be able to just provide a button and say roll back to the old version, and you would need to restart your nodes, and then you have the old cluster back with the 5.1. So this is how we plan on doing it. It's in development right now. I think we're going to have it in about a month or two. So yeah, but because we don't have any local storage and we have like a centralized storage, it's very easy to do, and we have the snapshotting capabilities. I think you can do some snapshotting on local disks as well, but it's kind of different and it's harder to do.
Morning. How do you usually run the runbooks? Is it, do you run it locally, or do you have a server dedicated to it? How do you handle the orchestration part of it in terms of who's allowed to do it and how do you control that?
So we, our playbook, the one that I showed in the beginning, is actually in a Git repository, and all the company has access to it and can do pull requests if they want. Right now, I've started teaching the developers how to do that, how to, I don't know, do let's say an app upgrade or to push the code into production with Ansible, as we have that working already. So it's just, for now, operations does it, even though we are kind of a mixed floor, we all work together, DevOps way, but I wouldn't call it DevOps, everybody has their own thing. So they're starting to work with this and to push code into staging environment, and they already do this in integration. So basically, yeah, we provide access to them to use these, and also they can, the vagrant file I was showing you is also in Git repository, so they can just take it and spawn up a new cluster and they can run this.
Any more? You get it right.
Sorry, I promise I'll shut up after this. So, you talk about a DevOps approach. Can you tell me what you do as far as actually testing your validation of your playbooks themselves?
So as I said, we start off using syntax check, and we have the vagrant kind of setup for development, and I test them those. I'm planning on using server specs in the future. I don't know if you've seen it. I think it's very interesting, but actually I haven't had any time to work with it and to make like a testing scenario. I think it's very important to test, so that's why I created this vagrant thing. And right now I'm checking things manually. I have the application working in my vagrant setup, so I can just test things like the interface is loading. I can create a new account. I can drag and drop, I don't know, virtual servers in the interface. So that's what I'm planning to do. Server spec, like checking ports, checking MySQL state, checking things like that. And also another way you could do this is with my playbook, I could just add a monitoring server in there and add all the monitoring automatically in it, and then I can see what's down, what's up, and what's happening properly.
I might actually add a little bit as well. So this question cropped up at Config Management Camp on Monday. I was there in the Ansible room, and one of the things that I pointed out was that all of our modules, most of the modules, do have desired state in them. I don't want to use the word identity, it's used correctly. Desired state is what we're looking for. So most of the modules do check. So if you put in a file into place, then it checks the C files will be there and doesn't do it. So one of the things that I said to the guy who asked this question was, I would take the approach of testing the desired result. So test the app, test the web service, email delivery, or whatever, rather than test every single step along the way, because Ansible's doing that as part of behavior anyway. So make life a little simpler.
Just to add to that,
So we recently, most of the people in here are aware of Ghost that turned up last week. It was pretty horrific. One of the ways we dealt with that was we wrote a monitoring check that ran across all of the hosts to find out which ones were vulnerable. And then as we patched, we watched our monitoring go green, and then we knew all of our hosts were patched. Or you could take a similar approach here, so you write your monitoring check, and you're effectively doing test-driven development of your infrastructure. So you write your monitoring check that says, yes, this is what the server should look like, and until that goes green, you know your Ansible plays wrong. So that's just one approach that we're taking.
Yeah.
Hi there. Question about workflow. Let's say you've tested changes to your configuration in staging, and it's time to push the changes to the production.
Yeah.
Do you just, let's say, working remotely in a hotel, do you just VPN and run things manually from your laptop, or do you have like a dedicated machine that is handling all that? Is it automated, or is it minutes? Or
Well, what I tend to do is usually I run from my laptop, but if I'm remotely, if I'm remote in a remote location, I have a server that has all the playbooks, and I run them from there. We also do checks every week and see if anything got changed. So we don't actually modify anything automatically. We just make sure that everything is the same, and if it's not, we go and see what has changed, if anything changed. We don't usually get changes. Mostly what happens is we get updates or other things like that, and we do them, we schedule them and do rolling updates. Yeah. So it's a mix of things, actually.
So I think we've got time for just one more question.
Do you do anything specific with your Ansible console output, and do you have the additional logging output on top of that?
So not really. For the checks that I was mentioning earlier, we send an email out if there are changes, So if we have a change in a week, we just send an email out with the output of the Ansible output, so we can see what changed there. So that's basically what I do. Nothing much.
Okay. My question is about version. On the previous slide, you said about version control plugin. Can you tell us a bit more about that? So how do you handle version control for, say, a new version of Elasticsearch comes out? How do you make sure that the config doesn't break, etc.?
So you're talking about our internal things or applications for the customers?
Applications for the customers.
Okay, so for instance, for Elasticsearch, as I've said, this is still in development, so it's not ready. But for Elasticsearch, for instance, they have sort of a different repository for each version of their application. So if you just delete the old REPL file, let's say for CentOS, and you add the new REPL file for the new repository with the new version, and then just do an update, it automatically updates it to the newest version, the one that's in the new REPL. So that's what's happening there. So that's what we want to do with versioning. So we want to check also to be able to check and QA how is application X gonna go upgrading from version I don't know 3.2 to version 3.5 and see how it all goes and what needs to be done there.
You want to do one more? Any more questions? No? Marius, thank you very much.
Thank you.